Testing, 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 testing. Okay. Recording, sharing. Yeah, should be all the things good. Sorry, I'll be sorry, a little bit late. So, yeah, good morning, and then welcome to the second lesson. So this lesson, the first half lessons we will discuss about the traditional computer graphics. So all the things from the fundamentals, starting from the pixel, 2D, 3D, and then we will for the second half we will go to the fossil, we will go to the GLB, OpenUSD, Omniverse, etc. So today we'll study about the computer graphics, all the things from fundamentals. So I guess some of you guys have some knowledge about computer graphics. So maybe sometimes I will go to the Q&A and ask you some questions so that you can enjoy the lessons and answer the questions. Hey, yeah, you always find that this lesson, right, fundamental, we are talking about the CG computer graphics. We are talking about the Excel. We are talking about games. So because it's fundamental, it looks like the same, right? So games is here. Games elements contain the computer graphics. Computer graphic element contain the mixed reality. Mixed reality environment contain the games. They all like the same, right? But today, when you are looking at AI or machine learning, they are similar, right? So when you're talking about AI or when you're talking about the machine learning, they all talk about the neural network. They all talk about the network structure. So they are the same. Yeah. So the fundamental knowledge, or I will say that the background information, the background knowledge, they are almost the same, but there are lots of different users and different applications. So try to enjoy the universe. So try to enjoy this kind of similar things. And then starting from the similar thing, you can build up your application step by step, a little bit by a little bit. So the first thing we need to discuss is 2D graphics. Easy to understand, right? So I guess starting from your high school or middle school, you know something about the 2D graphics. So what could I ask? What is discrete data and continuous data, discrete and continuous data. This one is the LED screen, right? So is this data a discrete data or continuous data? Don't go to Wikipedia and search. All the signal, all the signal from our computer system, they are combined by the small element. And all the small element, they are discrete. So that's why they always say that computer world, all the things are virtual, all the things are from the small element, and they are not continuous. They are small part, small part, small part, and small part. Of course, today when you're studying about the physics, and then physics guy also tells you, hey, physics is also discrete because they can also bring into really small element that your sense or your eyes cannot be observed. But there is another thing. We always define our computer world as a discrete data. That means all the thing is combined by small signal. Image is like that, audio is also like that, and the other signaling is also like that because all the things from the fundamental, at least right now, we are using the binary. Later on, maybe you have the quantum computing and then you have the qubit, that's another thing. But right now, still binary. And then this is an image, right? Right? That is the smallest element of an image. So what is the name? Pixel. Pixel. Okay. All the pixel contain the value. So that is the color code. Color code. There are two color code. One is RGB. Another is CYMK. So what is the difference? RGB contain or generate the lighting. Okay. So this kind of projector using the RGB. Okay. LED using the RGB because they generate the lighting. They generate the light. So for the CMYMK, that means they cannot generate the light. So we don't have any painting here. Oh, yeah. So this is the paper. The paper can or cannot generate the lighting. Cannot. They just reflect the lighting and then they use the CMYK. Whatever. We do not care about the C. We are not care. We will not touch the printing. We only touch the all things screen. So the color coding of computer graphic is LED screen is RGB or CMYK. This screen is RGB. Okay, RGB. They generate three lights: red, green, and blue. Okay, starting from 0 to 225. So they have 276 different variables. Okay, 0 to 226. So I would like to ask if the RGB code is 000000. So what is the lighting? White or bad? White or bad? Who say white? No one. Who say bad? Someone say white, someone say bad. RGB is generate the lighting, right? So if I said that the turn off the red, turn off the green, turn off the blue color, so what is the lighting? Turn off all the lighting. Then it's bad. Okay, it's dark. It's bad. Okay, so 000000 is bad. So always remember this one. And then if you turn on the red lights, for example, you turn on 255 for the red and then 00 for the green and then blue, then it's red light. For the others, you have different combination. Of course, usually we do not present in 0 to 225. We use 16-bit. So that's why we have the FFFFF and 000. Yeah, 0000. Yeah. Okay? Okay? Black and white. Black and white. For the other color code, then don't ask me. Go to your Word, Excel, Photoshop, whatever. Just use the card mixer to work with this one. Okay. CYMK is for printing. So what's VR? VR is using similar. The VR right now. Okay, right now we are still using the fat screen. We are using the LE screen, fat. So they are still obey this kind of color code and also this kind of setting. So that's why you have different pixel. So you have the pixel about the high definition, and then you have the 4K. Okay, of course. I would like to ask, what is the highest resolution of the VR right now? Vision Pro, right? So what is the resolution? Do you remember? More than 4K plus more than 4K. Okay. Some of the maybe Quest 3 they say that they are 4K, but their 4K is only one screen. That means you are sharing 4K with both of your eyes. But Vision Pro they are saying that they are sharing 4K plus 4K. They are more than how many? It's 4K plus 4K, more than 8K right there. Okay, the resolution is more than 8K right there. So there are lots of pixel in the Vision Pro. So 4K means that you have more than almost 4,000 times more than 2,000 pixel, small element inside with more pixel, and then you will see that it's not so chipset patterns, and then you can see more realistic image. Okay, so you have the pixel, you have the color code, and FPS is frame per second. Frame per second. Okay, frame per second. So frame per second means that, yeah, starting from image, we are called discrete image. Small elements, small elements, small element. If you turn it into video, it's the same. It's a image, image, and image display in a very high frequency, high speed. Okay. Frame per second, that means how many image that I can give you within 1 second. Okay. When I was young, most likely it's 25. Okay, 25. And honestly, I cannot identify the difference between 25 and 50 and more. 50 is okay. 50 is okay. And more, usually I cannot I cannot identify. So who can say that my monitor or my high performance PC, gaming PC is using more than 100? So can you identify the difference? Yes. So you are the so you are the new generation, or I would say that you are the new people. Oh, we are somehow about a little bit older. So up to now, I'm using 25. I'm using 25 in my office because I'm only focused on the yeah, paper Word, and most likely I want to save more resources. Try to think that generate 25 image per second and 100 image per second. The computation power is totally different. And for the VR, how many frames per second? Suggestions is at least 90, at least 90, at least 90. And 90 is generally for your left eye and right eyes. That means they are generating more than 180 image per second. Left eye and right eyes, they are generating different image. Okay. Although they are using the same, they are using the same pixel. Their pixel is divided. Vision Pro, they are 8K, but for the Oculus or the other, they are using the total is 4K. But the left and the right, they are generating different image. And then their camera settings, their perspective, all the things, they are different. So that's why the VR PC needs a VR application. They need a better gaming PCs like that is here. Okay. Again, yeah, not again. So next one is the image file. So image file can be divided into two parts. The first one is the compressed. The second one is the uncompressed. Uncompressed, that means I display all the color code one by one. So do you still remember we have this one, right? Right. So if I want to store the data of this picture, so I will store 157, 163, 174, one by one, one by one, one by one. Okay. If I store all the data according to the pixel value, that means here we are uncompressed. Okay, uncompressed. I store the original image. Uncompressed, you have lots of um um good, good. Yeah, it's better because somehow it's uncompressed and all the thing is so real. And then if you do any editing, you can bet and then to the original image or to the original image is perfect. Uncompressed file is perfect. The only problem of the uncompressed file is the file size is too large. That's why you have JPEG, MP4, MP4, etc., etc. Okay. They are compressed file. Some of the compressed files they have the loss, especially about the JPEG and MP4. Okay, they have the loss, data loss. For example, JPEGs, they are losing around 98%, 97 to 98%. Okay, 97 depends on the JPEG 2000 or the other format. You are losing a lot of information inside the JPEG. Okay, so that's why if the image is 100 meg, so you only use 1 to 2 meg to store your image. Okay. So here, come to this one, you have the compressed file, you have uncompressed file. Uncompressed file is good for the quality. Compressed file is good for the file size. So when you are using the games, VR, AR, which one is better? This one or this one? I guess you have learned the Blender or Maya or Max, etc., right? So when you are learning Maya, Max, so which one are you going to use? Which one? Or when you are preparing games, what your previous teacher suggests, compress or uncompress? Uncompress is yeah. Which one? Game, file size, or better quality? Both file size and the better quality is not the consideration. The consideration is the runtime of your GPU because the most expensive part is your GPU card. Agree or not? Yes, right? Hard disk is cheap, right? So what is the most expensive part in your gaming PC? GPU, right? So you don't want to spend extra resources for the GPU to compress, here, right? To use the compressed file. Because for you, for all the compressed file, when you use in your games, you have to uncompress it before the display. Okay? And all the things when you uncompress it before the display, it takes time. Okay. So I always say okay, so I will try to forget about it. So that's why when you are preparing the texture of the 3D object, the texture of the game, they always say that it's used in TIFF, or somehow we always using the uncompressed file format, because for every frame per second is only a little bit really short period of time. And this short period of time, you don't want to spend extra resources to do any uncompressed the file size. How say that? You don't want to decode. Okay, better. You don't want to decode the compressed file, so you use the uncompressed one. Okay, okay. That's why you can think that if you are using games, if you are using VR application, VR application, BMAT, T-file, they are the best. Okay, put it into your PC and then I can directly use it. They are perfect. Okay. Of course, you say that hey, it costs a lot about inside your hard disk. It costs a lot in your memory, etc., etc. But compare with the GPU and then compare with the VRAM, is wearable. So we use this one. Okay. And that is here. So TIFF file, we always use the uncompressed one because when you are using uncompressed file size, TIFF, so it can be your performance of your runtime can be improved. So that one is perfect. Of course, if you have settings that the file size is small and then you have some special chips or special algorithm for your compression, we can still use a TIFF1, especially when you prepare the video. Prepare video, sometimes we use the compressions. Be, Somehow, when you are going to render 1 second, I can spend 3 hours or 4 hours to render one frame or 1 second. Movie is okay. We can always have the pre-render videos, but for the games, all the thing is rendered in the real time. So we use the uncompressed one. So that is our selection. In this course, we will discuss lots of different file formats, and then later on also we have similar things. We will discuss lots of the methodology, lots of the different game engine. There is no correctly right or wrong. The only things you need to learn is how you mix your justifications and explain your justification, especially when you are inside during your exam. You need to explain why I use the compressed one, why I use the uncompressed one, etc., etc. You need to learn the reasoning. You need to learn why I select the correct file because somehow you need to make the decision. So yeah, more about the 2D graphics. So when you want to capture the image, so there are two cameras. One is RGB, another is RGBD depth camera. RGB is easy to understand. You want to take a picture, so they all belong to the car code. Just like your iPhone, the gear camera. So you have the how many pixels do we have for the iPhone 16? I can't remember. How many pixels do we have? iPhone 16 or iPhone 15? How many minutes? 500? 48. Okay, okay. Okay. Anyway, because it's too large. Somehow I'll always forget and then I update too fast. So it really depends on the how many pixels you can collect in one frame. So this RGB camera, they use the RGB color exactly the same as our vision. But when you are talking about later on, we will talking about the VR, we will talking about the 3D reconstruction, and then we have another camera. This one, depth camera. They are using the infrared. Infrared. So using the infrared means that similar to this one. I know the 3D structure. I know the 3D structure. For the RGB camera, you do not know the 3D structure. You do not know the depth. You do not know whether it's flora or whether it's wall, etc. But with the depth camera, I can know the 3D structure. Similar to your iPhone, in your iPhone, you have the front camera. They are infrared. They are depth camera. So why the front camera, they give you the infrared, the depth camera? One question. Which one is more expensive? RGB or RGBD? RGD, depth camera, infrared is more expensive and they cost more energy. Okay, so that's why they hate to use the depth camera. More expensive, easy to understand, right? So It's a iPhone. But now you buy a you buy a mobile phone. When I'm a university student, usually I will only spend 2 to 3 thousand to buy my mobile phone, my phone. Okay, now you use 10,000, and then few days ago you have the Huawei new phone, right? So exact remember is 20,000, and the free screen free 30,000. Yeah, it's more expensive than my PC. So it's hard to understand. But they all still they want to lower the budget, cut the budget because they are the merchants, right? So somehow they want to put the budget as low as they can. But whatever, depth camera is more expensive and depth camera costs more energy. But why? The front camera, they use the infrared. Why? Because the front camera want to detect your Face ID. Face ID. If you are using the RGB camera, I can download your image from your IG, WeChat, or all the things, and then using your image to unlock your smartphone, right? Right. So they concern about the security. So that's why they use the depth camera. They scan the 3D structure of your face. Of course, you can say that still I can use the 3D printing or I can use the other things to unlock your camera, but at least it improve a little bit about the security. So they give you the front camera. Sometimes we use the depth camera and it's a must because we want to know the 3D structure. Many years ago, around 5 to 6 years ago, when you want to do the 3D scanning, the room of this room, etc., 3D camera the depth camera is a must. But today, because of the computer vision, because of the algorithm, somehow we use RGB, we can calculate the depth. We can use the algorithm to calculate depth. Of course, there are lots of computation power, but still we can do it. So depends on the technologies, computer graphics, or also the algorithm. They're improving and improving. And then of course the depth camera, they are also improving the quality resolutions together with the power consumption. So let's see which one is better. So this one is around few millions, right? RGB camera usually is few millions. So can you guess what is the resolution of the depth camera usually? So this one is few millions. So how about this one? Depth camera. So mostly, if you buy the high home use model, for example, you buy the Microsoft Asia Kinect. There are there are three depth camera, and each of the depth camera is around 600 something times 400 something. Okay, the pixel cannot compare with the RGB quality. Pixel. Yeah, depth camera also have the pixel. Depth camera also have the pixel. So compare with the resolution, compare with the money, compare with the power consumption. Depth camera is not so good. But somehow they can scan the 3D structure. Okay. Coordinate of the coordinate of the 2D um 2D image. So it's easy, right? X-axis and Y-axis, that is. Okay, so now you understand the X coordinate and Y coordinate. But the starting point of the production sometimes will be different. For the view coordinate for your editing, so most likely the origin is here, 00, 00. But when you go to the device, screen coordinate, the point is here. The starting point origin is here. So sometimes they will remap all the things. And you see this kind of the coordinate system, you need not to care because Unity or for example, if you are using V.js or the other VR tools, they will handle the coordinate remapping for you. So only we care the origin is here, 00, and we use this coordinate. Animation. So animation, yeah, similar to the previous one. So we have two kind of animation. The first one is here. Here, so we will have the image spirit. Okay, so one image continued by another, continued by another, continued by another, and then when you pay the image together. So you have an animation. But now we have a better production for the 2D animation because we borrow the thinking from the 3D animation from the 3D video production to the 2D one. So we will try to give the skeleton to the 2D cartoon character or 2D character. And then they have the skeleton. After they have the skeleton, then you can move their hand, you can move their arm, etc., etc. So you can do a little bit animation here. But whatever, this one today, you also have the stable diffusion, right? Or the solar. So it goes to another level. But don't worry, later on we'll talk with this kind of thing. This one is only the fundamental. So you know that this one is the first generation, image by image, and then you will have the skeleton to do the animation. Then now you also have the AI to input all the things. So if you are looking at the last year, our student work. So we'll teach you how to use the text to animation. That means I type in some information, text to generate the animation, text or animation. So when you type in some wording, so the Unity AI fields, they will automatically generate the animation for you. And today, you need not to download the animation. You need not to select the biped. You need not to do all the things. The only things you need to do is just learn how to communicate with the AI, how to type we call it prompt engineering, right? How to type the word into the AI, and that's it. So last Monday, this Monday, so the Apple guys come and then discuss about the Vision Pro with me, and yeah, it's really funny that they told me a story. So this year, the winner of the WWDC competition is girls. And I would say that when they have a look with the final ones, most of the um, most of the people go to the final one of the WWDC, they are all girls, and they are not from computer science. They are from business, school of design, etc. Okay, do you know why? Boys, do you know why? Yeah, I'm sorry, a little bit sexual discrimination. The Apple guys say that, yeah, because they are beautiful. They are beautiful Korean girls, and then they wear a really decent shirt, and then they have a best presentation, etc., etc. That's why they win the prize. But honestly, the reason why they can, most of the girls from the business and also from the School of Design, they can go to the final one of the WPC because now they did not need any developing skills. The only thing they need to know is this discover or understand the needs of the human and then use their wording to explain to the AI. AI can generate the apps for them. They use the app, do a really beautiful presentation, and then present for the judges. Then they can win the prize. They won the competition, right? Right. So today, yeah, we will still teach you about the core because we are the computer science, and then we will also teach you about technologies. But today, the most important thing is the idea, how you can mesh the human need and the technologies together, and using the idea to sell the other. For all the production, honestly, they can handle by the AI, they can handle by the generative content. So yeah, so that is the problem. And guys, boys, so where what is your future? Yeah, girls, they can understand human better, but honestly, don't worry because al 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 alas, you will need to find someone to prepare the algorithm. You need to find someone to go to Google, Open AI, and all sorts of the big company, and then do this kind of fundamental programming. And still, you have your job. So now you will be too extreme. Either you are really good in communication, really good in communications, and then really good in understand the needs of the human, and then you can generate the idea and you can be the winner of the society. Or either you have a really deep knowledge of the AI, study about PhD, study about the all sorts of the information about AI, machine learning, etc. So there are only two ways. So do you know how you can go to OpenAI or Google or Microsoft, etc. to become their AI engineer? Do you know? So at least you are the PhD graduate from the QS 100 university. So that's why there are so many students, your seniors classmates want to study the PhD because the entry level, the entry is the PhD. That is the truth. Okay, so we are working really good because at least now we are QS 57. Maybe few years, 2 or 3 years later, so we'll go to the QS 50, and then I guess go to the QS 50, we can stop right there because it's always top 50 is enough, far more than enough. But if you can graduate in our university for the PhD, you can go anywhere and then apply your job, even in the big company. Okay. We will learn more in the games. We will learn more about how the AI and how the 3D lighting, etc., to handle 2D work. So whatever in whatever in next semester you have the course about the AI and the game designs, and also this year you have the AI generative content in School of Design. So we also teach you, and then this is the new directions of 2D graphics and games, and yeah, it's really promising um um directions for you. So yeah, but you have the strength, right? At least you have the mathematical background, at least you have the machine learning background, and then I guess you can communicate better or understand which tools or which AI model is better to fit your application. So idea coming from how you can combine the human needs and then technologies together, right? So at least you have this part, I guess. Yeah. So try to understand more about the human needs and then win the prize or become the successor in the society. So 2D graphics is like that, and then we will move very fast. We will go to 3D graphics. 3D graphics. So what is inside 3D graphics? Tell me. So this one, what is inside 3D graphics? Tell me one by one. For example, this screen. So what do we have? The first one we have is a 3D application. So can you name some element inside the 3D application? Model. Yeah, the first one. Yeah, of course. Usually usually, usually we will feel embarrassed when you cannot answer the question. So most of the lecture will just put the answer on the lecture slide. So see that? So just try to read the lecture slide. Honestly, there are only few words on the lecture slide, right? So yeah, try to give us some response to let us know you are here and then you are studying our course. The first one, of course, the fundamental of the 3D graphic, 3D object, 3D object. 3D object is what we are used. And then if you are using Maya or if you are communicate with some computer graphics guys, designer, etc., they are using Match. They are using Match. Or somehow they will use the polygon from the computer science. Computer science will use the polygon. Polygon is just like here. So basically, a polygon is a combine of vertex. Vertex. So there are lots of vertex. Three vertex together will draw a triangle. And this triangle is the face. Lots of the face combine together and it become a polygon. Okay, so easy understanding, point or vertex. Three points together, a triangle, a face. Many face together, a polygon. A polygon. Polygon is a wire model. They do not have anything on it. It's just like wire, they connect with each other. So we will give the texture onto it. Texture, easy understanding, will be a bitmap, or you will say that it's a JPEG. But better, we are in a professional way, most likely we use the TIFF format, TIFF file format. And this one, for each triangle, we have a image, and we have an image. So it makes a 3D model look realistic. So there are two ways to let the 3D model look realistic. First one, more points, more points, more points here. Okay, when you have more points, you have more triangle. When you have more triangle, you can have more calculation of lighting. calculation of lighting. And then you will, when there is lighting here on my face, so you will have different shadow on my face. You have the gradient and it looks realistic. First one, more polygon, it looks more attractive. Second one, better image. Better image. So somehow we want to decrease the calculation, decrease the usage of the GPU, will decrease the polygon. If we still want it to look better, ask the 3D artist to draw the shadow on the bitmap or on the polygon, so it looks realistic. Of course, it's fake, but it looks realistic. Especially when here, can you see that there are some, how to say that, there are some 接埋, how to say that? So so here is one polygon, right? So when you want the process look realistic, so somehow you can ask the 3D artist to draw the shadow similar to this one. Less polygon, ask the 3D artist draw the shadow, it still look realistic. And of course, it's fake when you go to different lighting, and then it looks really strange, but it helps for all the calculation inside the computer graphics. All the polygon here we call it widget body. Widget body. What all the polygon inside games when you are one time we call it widget body. In Video Store Max, Maya, Blender, etc., you can modify the position of the pawn, right? But inside the game, we will not modify the position of the pawn. And they are called widget body. Widget body. Widget body. Widget body, a more professional computer science term, is non-deformable body. That means they will not change the shape. That means I will not change the position of the vertex, position of the pawn. Why we have this kind of operation? Why we use widget body? Save the computation power, because liquid, gas, or the deformable object cause loss of the computation power. So we use the solid. We will not change the shape. Whatever you bomb or wherever you crash or whatever you do anything to the car, most likely they are widget body. They are widget body. You find that, hey, some of the, for example, Microsoft Forza 6 or etc., there is really a bomb here when I hit some object. They change this part, this video model over there. They change another 3D object. They change into another one. They just replace the 3D object within a very short time. Okay, so they are still widget body. They just change small part of it. Okay. 變面咁樣說啊，變面有沒有聽過嗎？ It's okay. So all the things inside the game is an illusion. So yeah, we have mentioned about this one. So I will always say that the video object inside game looks like this kind of Chinese traditional 紙紮公仔. When you are in the Ghost Festival, so there are lots of the people doing this kind of thing and then burn it and then to expect the respect to the ghost or respect the respect the show the respect to the ghost, right? So I always think that the idea is copied from this one. Anyway, so we continue. So inside the why the 3D model can move or can do the animation. Today, we will have the skeleton inside the 3D model. Skeleton, just like a biped. Skeleton is biped, they are the same, right? Skeleton and biped. And then inside the skeleton, so there are lots of the points responding the joint of your human body. So we call it humanoid, okay, humanoid. So each point, they are called end effector. When you hold their hand and then move the end effector, according to the IK, the other parts of their body, they will move together. Okay? And then when you move together, So each pawn, they are connected with a link, and then each link there is called something called capsule. And then capsule, they will control a certain number of the polygon right there. Okay, so when I'm moving the n director, n effector right there, and n effector, n effector, n effect knobs and knobs, and then in the middle there is link. Link is covered by the capsule. Capsule control the pawns, and all the pawns will be moved. Okay, so they use the skeleton to move the whole character, to move the whole character. Today, nearly all the animal in our world, they are they are with four legs. Okay, they are four legs. They are called humanoid. So whatever is a tiger, is a bird, or is a monster, something like that. So we use four, four, four legs as our presentation, and this one we call humanoid. And also nearly all the 3D objects they can share the same skeleton, and then the animation they can share with each other. Of course, there sometimes maybe there are some problems. For example, if I'm fat and then the motion capture character is really thin, so the arm will be go into the body. So when you are playing games, you have this kind of the effect, right? So the 3D animator will edit the 3D animation time frame by time frame. Okay. So maybe they will find, hey, this one, the motion capture data is not correct. So they will move the arms here a little bit and then make it better and then make it more realistic. Or nearly all the games, all the animation in the games, they are pre-recorded animation. Pre-recorded animation. They do not generate new animation inside the game. So maybe one character, you have 5, 6, 7, 8, 9, 10, etc. You have limited number of animation. They prepare inside the Blender, they prepare inside the Video Studio Max, and then when you go into the games, they just play animation 1, animation 2, animation 3, 4, 5, 6, etc. Okay? All the things inside the games, inside computer graphics, they are predefined, pre-record. Okay, so yeah, we have covered the polygon, skeleton, animation. So you have the polygon here, and then inside polygon you have the skeleton. One skeleton, you can have multiple animation. Usually one polygon, one skeleton, one skeleton, many animation. Okay, got it? Okay. So yeah, we have mentioned most of the character. They are humanoid. That means they are four legs. Whatever is bird, cow, dolphin, whales, etc., etc. So they are these kind of things. Polygon usually we generate from a crib. So 10 or 20 years ago, so most of the 3D 3D modeler, so they will starting all generate all the 3D model by using a crib. So they extrude the face, divide the face, and then and then modify until the final product happens. So this one is according to your muscle. Is according to your muscle. Okay. So the pawn distribution is according to your muscle. Why it should be according to the muscle? Why? This one. So you generate, for example, brush here. So you generate a muscle just like this one. And then arm, you also according to your muscle. So you have what is the muscle name of this part? 二頭肌. And then you have another muscle here. So they generate the muscle generate the 3D model according to your muscle. Okay, why they have this kind of model? Yeah, why they have this kind of process? Why? Why I need to generate the 3D model according to the muscle? Animation. Okay, it looks more realistic. Okay. So that is the 3D animation. Try to finish all the things within 45 minutes, and then we will have a break and then continue. What's that? 3D render, 3D rendering timelines, 3D animation or 3D graphics games, rendering timelines. All the things in your Blender, in your games, they are 3D. They are 3D. But finally, on the LED screen is 2D. 2D. Okay, so you need to do the remapping. Remapping means that you have the application, you have the 3D model, you have the 3D coordinate, you have the camera positions, and then I know the final screen of my output. So I map all the 3D graphic into a 2D screen, onto a 2D screen, and then display to your monitor or LED screen. So this one is the rendering pipeline. Rendering pipeline. Easy understanding is I transform all the things from 3D coordinate, 3D things to 2D. Okay, 3D things to 2D. Easy understanding is here. Have you played the Paper Mario? Yeah, that's good, right? Not too old. I haven't showed you the Game Boy Mario. Paper Mario is if you have played the Paper Mario, it's easier to understand. So you have the roll coding, so here. Okay. So I would like to ask, what is the how to say that? What is the plane of the terrain of the floor? XYZ. Which one? Which two? So I'm working on XC. Okay, I'm working on an XC plan. Okay, so if I'm jumping. That means I'm trying to changing my Y coordinate. Okay, I'm changing my Y coordinate. The terrain is XC. Okay, so you have the XC plan here, and then you put the camera. They have the camera position, camera look at, and camera up. Three vector. So after you have put your camera right there, so through the screen, I can observe the 2D coordinate. It changed all the things from 3D to 2D. And then and then real coordinate will be here, 2D coordinate here. And then if you mark to the screen coordinate will be here, origin 0. Okay. VR is similar. VR is just putting a camera next to this camera. So we'll explain it later. More about the vector and the matrix, because vector and the matrix they are the fundamental of our computer graphic. In fact, the fundamental of our computer graphic contain three things: vector, matrix, complex number. So that is the three basic mathematics that you have to understand and have to know well before you go. Yeah, application is okay, I think, but if you go to research or if you study a little bit more, this three is the most or I would say the fundamental thing you have to understand in computer graphic: vector, matrix, complex number. Okay? So vector is easy to understand. It's just like a coordinate system, but they have the direction. They have the direction. They are pointing something to from somewhere to somewhere. Vector, you can do the calculation. You can sum together. You can minus. But the most important things we want to do is the cost and dot product. We'll discuss later. Vector can be used to calculate the physics. For example, I throw a ball. Okay, I throw a ball. So I generate a force with a vector, just like this one. So they allows me to calculate the projectile movement of a ball, and then they give a force of a ball, and the ball will continue the movement according to this vector. Of course, there is another vector is about the gravity, so they will push the ball down, so they have the projectile motion. Okay, vector can be used in the physics, in the lighting, so we'll discuss later. If you want to know, you have learned in your high school, right? You have learned vector, right? But you haven't learned vector, it's okay. If you are doing your assignment, go to the calculator. Even now, I do not calculate if if I want to ask the vector calculation in the examination, I will let you know. I will let you know. Okay. But if it's only assignments or also things, use the vector calculator. Okay. Calculate if you have two force here, what is the resultant force, etc., etc. And then the most important things we want to know about the vector calculation is called cost product and dot product. Cost product and dot product is the most important thing calculate the lighting. why the 3D graphics look so well? Because we have lots of the lighting calculation. And how to calculate the lighting is from the vector, cost product, and dot product. Okay, cost product is like that. So we have the for example, we have two vector. So a free how would say that? Why I've tried to focus. Anyway, so for example, I have two vector, and then I want to know the vector, the normal vector that is perpendicular to this triangle, to this face. Then I will use the cost product. The cost product, the calculation is cost product is just like this one. So if I ask you, I will test the lighting calculation in the examination, put a star on this line. Okay, this is or maybe, yeah, if I'm kind, I will prepare this one as your supplementary exercise and then let you know what is the cost product calculation. So I will explain the cost calculation right there first. So there are three-dimensional vector, right? X, Y, Z. So you have the vector one, you have the vector two. Okay. So 3, -1, 2 is here, and then -2, 3, 5 is here. Okay. Okay. Then we will calculate the new vector coordinate X, Y, and Z. So they will have the positive, negative, and positive again. For the x vector, when you want to calculate the x vector, you will here plot this part and then calculate the element over there, element. And then you will have the cost calculation. So -1 times 5 minus 2 times 3. Cost. Okay? Cost. If you are calculating the y vector, mask this part. Mask this part. So you will have this part and this part. Okay? If you calculate the z, it brought the Z part, and then you have this one. You also do a cost calculation of this one. So finally, you will have the new vector X, Y, and Z. And then you will have a vector. See, that's when we have the X, Y right there, and then we have a normal vector is here. And this normal vector is perpendicular to the triangle, to the triangle. I will explain when we need to calculate the perpendicular new vector. So another calculation is called the dot product. Cost product is going to find a new vector. Okay, cost product is going to find a new vector, but dot product is going to find a new scalar. That means one number only, one number only, one number only. So what's the calculation? Is using the magnitude of the p vector and the magnitude of the q vector times the cosine theta right there, right there. So why we have this kind of calculation? Because we want to calculate the lighting. So try to see that there are 1, 2, 3, three face right there, right? Three face right there. And then we have lots of different triangle, lots of different triangles. So each triangle, I'm sorry, I used the rectangle here. So each of the face here, so I want to find a vector that can represent this face. And this is the perpendicular vector. With this perpendicular vector and with a vector that is pointing the lighting, we want to calculate the angle. And this angle is the dot product. With the dot product, you will have a scalar here. A scalar is the lighting, is the light intensity of these phases. So what? So at the very beginning, if you the 3D model, you only have one color. For example, this one is the green, right? Because of the cost product and dot product, and then calculate the angle between the lighting. You can have different light intensity, and all these phases have different color on it, and it looks more realistic. Okay. Just like this one. So it's only one color, the ball. We only have one color. But because this ball, there are lots of triangle faces here. And each of the faces, they have the different normal pointing to the other different directions. And then we can use the lighting between, we can use the dot product between the lighting and the normal vector, calculate the light received by each phases one by one, and it looks better in the 3D environment, and it's kind of illusion. Okay, cost and dot product, if bigger than zero, that means they are if the normal if the normal and the lighting intensity return the dot product that is bigger than zero, that means they are facing the lighting source. If they are facing the lighting source, that means it's bright. If it's negative, that means they are not facing the lighting source, that means it's dark. Okay? Easy understanding is this graphic. What is the name of this character? What's the name? 他叫什么名字啊？林克 Link is better is better Link，因为很多人说他就是塞尔达吧，塞尔达是哪个公主？是塞尔达，Zelda 是哪个公主？她叫 Link。And it's really strange, right? This character inside lots of the game, inside lots of the series, I can I cannot find he speak any one sentence。他有说话吗？有说话吗？真的有吗？Anyway, it's not the core of this lesson, and length is not the core of this line. The core of this line is the triangle right there. Triangle here. So we are changing the lighting source, and then changing the lighting source, the color of this triangle is changing. Okay, so how we calculate the color of this triangle? And triangle is one of the main element in theta in length. So yeah, there are lots of interesting ways. Whatever we can talk later. So this triangle, so you have the A vector, you have the B vector. A vector and B vector, you can calculate a vector that is perpendicular to the A and B vector. That means using the cross product, and then you can find the normal. Find the normal. So after you have find the normal, so you can also calculate by the dot product, find the angle between the normal vector and then the lighting vector. And that is the angle. So after you have this angle, you can calculate the lighting. Okay, okay. So the step is first do the cross product, do the cross product. And then second step is do the dot product. I'm sorry, it's dot. Why? It's a dot, okay? It's dot product. And then you can find out the result of this one, okay? And that is the most important thing of the vector that is used in the game, in the computer graphics applications. Second one we use is the matrix. Matrix is similar to this one. Okay, it's a series of number. It's a series of number. So why we need to use the matrix to represent? Because we want to in games or in computer world, after the Blender, after the Visual Max and Maya, when you put into games, you can only do color is another one. But for the 3D object, the geometry called manipulation, you can only do 3 manipulation. Translate, rotate, scale. Nothing else. Okay, translate, rotate, and scale. And if you want to do this kind of translate, rotate, and scale, so you need to remember the form of the matrix. For example, I want to teleport my character from this point to this point to this point to this point. I'm using the translate to translate the 3D object from this point to this point to this point, etc., etc. So if you're looking at the game production or 3D production, so all the walking, they are just moonwalk. Okay? They will not move forward or backward. Why they can move forward or backward? You teleport them a little bit, a little bit, a little bit, and a little bit. And that is what is the creation is in here. And how you teleport? Translation. Okay? XYZ, new position of XYZ. You can also rotate. So this one is the Y rotation. You have different rotation. You have X, Y, Z. You have X rotation, XSS rotation, CSS rotation, and YSS rotation. So similar to right now here, when I do this kind of rotation, what is the SS that I'm using? Which one? Which axis? Y. Y. Okay, Y. Okay. So Y is the most important rotation in most of the games. So you have the Y rotation here, and then this is the calculated by the radians, not degree, radians, radians. Of course, you can use the compare graphics. You can use the mathematical function to translate the radians to degree, but the calculation inside is using the radians. That means using the pi and 2 pi. Pi is 180 degree, 2 pi is 360 degree. Okay, and it's the format of the y rotation. So, the yeah, again, in your examination, if I want to test you about this kind of calculation, I will let you know first before the week 13. And then I will post this one, the supplementary post it on the supplementary exercise if I want to ask. But usually in this 4 to 5 year, we will not do this kind of calculation for the postgrad because I don't want you to become a calculator. If I put one of the major manipulations in your examination, most likely you will spend 30 minutes, 15 minutes to 30 minutes to calculate cosine theta, sine theta, and then calculate the each element one by one. So you spend lots of time on the calculator, and I think it's still but scale, X scale, X scale enlargement, Y scale enlargement, Z scale enlargement. If you want to just like the Mario eat the mushroom enlarge together, so original is 101010, then you will turn it into 202020. Okay, okay. So yeah, if you want to do nothing, so you have the identity matrix 1111 in the diagonal. So this one is the matrix production. So yeah, if we need to test it in the examination, I will do it again. So anyway, it's not good for you to do. So this one is the 2D matrix manipulations. So what is the things you want to do because you want to manipulate the new position or new manipulation of the video object. So they have the original status. They have the original status. And then you give one new matrix to translate, rotate, and scale. So after manipulate with two matrices, you have the another one. Okay, you have another one. The details calculation, I don't want to cover away there because again, I don't want to turn you guys into a calculator and then you just know there are matrix calculation to control the scale, rotate, translate, and that's it. Okay, that's enough. Orientation. So why we need the orientation? We have mentioned about the vector. Vector is for the physics, is for the lighting calculation. Lighting is also a physics. Most likely vector is for the physics. And then we have the matrix. Matrix is for the rotate, translate, and also the scale. Then we have another one called orientation. It's also for the movement. It's also for the movement. So why we have these kind of things? So let us have a look with a demo first. This one. So have you watched? Do you know do you know Marcos? You know Gundam, right? Yes, right. Anyway, so there is another ro robot cartoon that is really famous. It's called Hey, hate the computer. It's called Marcos. Marcos, I think it's more realistic because 诶 So we have learned the matrix manipulation, right? Scale, rotate, and translate. Scale is not here, but when you're playing with the jet fighter, when controlling the jet fighter, so there are lots of translate and rotate at the same time. Do you agree with that? Yes, right? Translate and rotate, translate and rotate, translate and rotate. So many years ago, when you're playing, this one should be PSV, PSV or PS3. I'm not sure. Anyway, I've played this game. So can you see that? When you are controlling the jet fighter, suddenly the camera need to be reset. Can you see the effect? Suddenly all the camera reset again and continue. So it's really bad feeling. So when you are playing a jet fighter games, when you are using a camera, follow the jet fighter, and then they always ask you to reset the camera, reset the camera, reset the camera. You lost the feeling. Why this happened? Because we now we are living in the three-dimensional world, right? Yes, right. So if some of you guys study about physics, it's a three-dimensional world. How many dimensional do we have? Some of studies physics, they will say that we are living in a 16 to 17 dimensional world. I'm not a physical expert, so I'm not sure what's going on. But honestly, even in the computer world, when you are using the 3D calculation to calculate the computer graphics, there is not enough parameter to do it. There is not enough parameter to it. So we need to have more parameter to calculate the to calculate the manipulation, to calculate the translate and rotate together. Three-dimensional parameter is not enough. We are not living, even in the computer world, we are not living in a 3D computer world, three-dimensional computer world. If you want to calculate the three-dimensional computation, manipulation of computation, we need to explain our dimensional. And we have to explain our dimension from 3 to 6. We are using a higher dimensional calculation to calculate the result of a 3D world. That is what the physics guy doing. And in the computer graphics, we are using the same concept. We are using a higher dimensional mathematics to calculate a lower dimensional world. Do you understand what I'm meaning? If you love this kind of feelings, and then if you can understand this kind of calculation, go and study PhD. Because all the AI, all the machine model, they are always using a higher dimensional to calculate a lower dimensional. Or when there are lots of the higher dimensional thing, I want to reduce the dimension, etc. So they are always playing with the dimension, similar to this case. Why we need to play with the dimension? Because current mathematic tools, current AI is not enough, and some problem happens. Camera have to reset. The whole world calculation have to reset, and it's not good. Okay, so that is the screen is paused. I have no idea what meaning screen is paused. Resume. Stop sharing. Hey, I hate Zoom. Give me 1 second. We continue. So, next one. So we have a new mathematic calculation. It's called 3D. It's called 6D complex number. So now we are not using XYZ to compare the 3D world. We are using XYZ with IJK. Okay, so we are using 6-dimensional to calculate the 3-dimensional world. You have more power. When you have more dimensional, you have more power to describe the translate, describe the rotate with the parameter. So you have the new coordinate system. And then perhaps you can have a look with another one, so it's easier to understand. When you are using the measures to calculate, so it always happens something called gamble loss. And then gamble loss is just like here when you're moving the jet fighter. Yeah, just like here, gamble loss. So two axes is rotating, but the resultants but the results are the same. So when two axes align with each other, so wherever you rotate, the results are the same. And then we need to restart all the camera settings, restart all the matrix setting, and that is called gamble loss. So using higher dimensional mathematical tools to calculate the lower dimensional, that means using 60 to calculate the 3D world is good, okay? Because it can produce more realistic effect, movement effect to your computer graphics. But the calculation is really complicated and it costs a lot of computational power. Similar to the previous one, right? You only calculate XYZ. Now you tell me that for each time frame, not only XYZ, you also have the IJK together, right? You double, you double the resources. So only some application we will use the 6D complex number. Can you think about it? Which situation? I show you one, right? Then we'll use complex number. When we are playing, what is the game? What is our previous game that I've shown on the YouTube? When we are playing jet fighter, okay? When we are control the aeroplane, okay? When we can control the airplane, so you will have the rotate, translate, always have the rotate and translate together, then you use the 3D complex number. So if you are playing Super Mario, right? So your Super Mario rotate, translate, do all sorts of things in the 3-dimensional space together? No. The Mario will only work on the XZ plane. Okay? And there is, well, I would say that yeah, maybe there is gamble lot, but usually the gamble lot will not be happen because they only rotate the y-axis. The only things they do is rotate the y-axis. Mario will not, I'll say that, will not rotate like that, right? Will not rotate like that, right? So it's not, yeah, it's not the case. So this one, Jet fighter is one of the thing you need to use the Quaternion, six-dimensional complex number. Can you give me one more? Time limit? So we only wait for 5 seconds. No, okay. VR device. When you are controlling your VR controller head-mount display, you are rotating your controller in a three-dimensional space, and then you are rotate translate them at the same time. So you also need a 3D canvas number. So if yeah, that's why you study metaverse. That's why in our course, maybe in Richard's class or later on in SEC class, you always heard about the quaternion. You always heard about the three-dimensional, six-dimensional number because you are controlling the VR and they are rotate translate in the 3D display at the same time. So you need the 3D canvas number. Okay. So have we finished all the things? Not yet, right? I want to skip. Yeah, Unity camera settings. Yeah, we'll move faster. Camera setting. You have the camera position, camera look at, and camera up. You have three vector. Okay, and then this one is a flip terms. So you have the near plane and the far plane. They combine the near plane object and the far plane object together. So only the 3D object in this area will be calculated and will be rendered. Outside this area, we will not render because we want to save the computational power. Okay, so I would like to ask, this one object is bigger or this one object is bigger when you are observing the object right there? Near plane, right? So near object, the object is bigger. Always remember this one. Okay, okay. But we have another called parallel display. I would like to skip this one. I guess more if you have studied about the computer graphic is a basic one. Yeah, we have another one called parallel projections. Near plane and the far plane, they are the same. So most likely if you are yeah, lots of the AR application, they will change it into parallel projections because they are not going to render something far away from your observer, far away from the user. They want all the things will not be disturbed. So they use the parallel projections. So in the later course, VR AR, perhaps you can feel more about this part, perspective, and also the parallel projections. So you can play with different kinds of the projection later. Yeah, so we finish all the things about traditional computer graphics. And then 5 or 10 minutes, do you want a break? Yes, right? I also want a break. Yeah, 5 or 10 minutes. Do you want 10 minutes? Okay, 10 minutes. Okay, and then we will come back to continue our lessons. And then we'll move to metaverse, fossil, all sorts of things. So yeah, if you I guess you come here, this lesson is waiting for this part. So remember to come back on time. 10 minutes. So yeah, I know that you feel very tired. I also feel very tired. Ah. But anyway, so we will continue our class and then we'll finish this one. Maybe next lesson is better because next lesson Eric will come and then talking about sandbox, you will have some real tasks. Yeah, we'll have some real tasks to play with the 4C editor and then to play with the sandbox. So you have something to do and then you will feel not so boring. So yeah, next week Eric will come and then the sandbox that we have talked about. So nowadays, so most likely Metaverse want the user to generate the content, user generate content, and then user generate content allow the user to put some 3D model inside it. So different Metaverse platform they have different approach. For example, Spatial.io is still requires you to know Blender or video store mask. So you use Blender, you use video store mask to create a 3D object and then encrypt with NFT maybe, and then put it into the spatial.io, into the Unity or into the from Unity to the spatial.io or directly put into the spatial.io. But some of the metaverse platforms, they allow their user to edit, to create the content, to create the 3D model directly inside the 3D, inside their metaverse platform. For example, Minecraft, for example, Roblox, and for example, the sandbox that you will experience in the next lessons. Okay. So the sandbox will be one of the fossil. So this one is the fossil. Fossil. You have the pixel, right? You have the pixel. Pixel is 2D. So if it's 3D, then it's fossil. The basic unit inside the Minecraft or inside the 3D world. In fact, if you're looking at this one, it looks like 2D, right? But if you create by the user, usually they use lots of the crypt, and then each of the crypt they have at least 12 triangle, and there are lots of triangle here. Fossil game engine, the most important thing inside, for example, if you want to work inside the sandbox as a technical developer, so the most important thing they are doing is try to reduce the number of triangle into it. That means deduction, polygon deduction. Less face, less triangle. That means less lighting calculation, less vector dot product and cost product. So less calculation means that you can put it into your, now the sandbox can only run on the PC or Mac platforms. If it's less calculation, that means I can put it into iPad, iPhone, or even other VR device. And that is what they need. And if you want to work inside the sandbox, try to study about this part. And next week they will come and then you can express some of the thinking about that. Because as I have told you that one of the unicorn in Hong Kong is the sandbox, they can get, I guess it's $1 billion in last few years, $1 billion. So it's a huge amount of development cost and it becomes a really, really big company. They're good. They support our event for many years, and then yeah. So now they become a bigger and bigger programming. The things that we are studying is called dynamic program algorithm, how we can deduce the number of polygon inside it. We will talk more in the game engine course. We will talk more in the game engine course, most likely about the rendering. And another thing is about the new rendering. So all the rendering that we have discussed above is traditional computer graphics. Traditional computer graphics. That means we have the physics. That means we use the lighting algorithm. We use the also mathematical. We use some traditional physics calculation to calculate all the effect. But now we can do something more with AI. Even the rendering, we can add AI inside it. So have you heard about AI? They can do in-paint and out-paint. Do you know what is in-paint and out-paint? Many years ago. So when you have a image here, right? So we can do an out-paint. That means we can extend the content, extend the content, extend the content. In-paint means that, for example, I'm here. So some area here is mask. Okay, by AI, I can repaint this area. Of course, you have lots of different applications. Later on, we have the super resolutions, and later on, we have the solar. That means if you give me one image or stable diffusion, if you give me one image, I can generate the other image one by one to you and become a videos. So this kind of technologies can be also used inside the rendering. Inside the rendering. What's the meaning? Is that so? For example, I'm wearing a head-mount display inside the VR. Inside the VR, only the middle part of the screen that human want to focus. For the remaining part, do I need to focus? Not really, not really. So the remaining part, for example, here is the middle part, right? So here I use the traditional computer graphic to generate the lighting effect, to generate the image. For the outer size, I can use the AI to generate. I can use the AI to generate. Using the AI to generate, we can do two things. The first one is in the middle part, we can half-half. We can ask the computer, maybe, for example, they are using the 4K to we are not using the 4K. I can decrease to the 2K and then use the AI to do the super whack solution to fulfill the missing piece of one by one, one by one. Or outer side, I can fully generate by the AI. It's called outping. It's called outping. So only the middle part, we use the computer graphics. For the outer part, we use the AI. One of the algorithm we are using is the NERF, NERF, neural radiant fields. So let's have a look with the video right there. See that? So this one is using the nerve. Only the middle part is generated by the computer graphics. And then the outside part, yeah, generated by the computer graphics. And then for the outside part is generated by the AI. So can you find the difference? Can you identify the difference? Yes, maybe. But inside the VR device, so well, when you are playing, you only focus on the middle part. You will not care the outside. And that is what they are doing. The middle part here, the middle part still, I'm using the computer graphics. But for the outside part, I will decrease the usage of computer graphics because I don't want to calculate the faces, the faces of the polygon one by one, one by one, one by one. I just want to from the 3D to the 2D calculation. So I calculate the 2D estimation. What is the next one? What is the next one? Next pixel, next pixel, using the AI method to calculate. So it depends on lots of the things for the computation power. If your 3D scene is not too complicated, so number of polygon is not so many, it's not so many, computer graphic is still a possible choice. But if your polygon is so many, so complicated in the 3D scenes, perhaps you can put it into 2D scenes and then render by the AI, render by the LERF. Okay, left this one. We are doing research in this one around 5 to 6 years ago. But last year there is another one called 3DGS, right? And then 3DGS, the performance of 3DGS is much more better than this rendering algorithm. So this one becomes another question mark for the research direction. But lucky that NVIDIA say that, hey, we will put extra resources on the LERF to present the NVIDIA LERF model and see that whether LERF model can be revoked again this year. Last year, all the rendering, they focus on the 3DGS, and then the LERF become one of the competitors. Hey, I did better than the LERF, I do better than you, etc., etc. But I will let you know this kind of the rendering because the previous one is the old traditional. using the physics to calculate is the old traditional. And now they have some new trend to use the AI to do the in-paint and out-paint. The thinking is in-paint and out-paint, and then continues the rendering development to make it faster and faster. And that is what we are doing right now. Okay, how AI is doing. Okay. So yeah, this year we can not go to the Pixar, but for all the visitors, most likely I will capture the videos. So there is a 360 videos about the Pixar exhibition. This one is quite good. So because there are lots of the demo for you to pay, there are lots of the interesting things you can there are lots of the interesting demo you can play with the parameter, tune the parameter, and then understand more for the compare graphics, more about my previous lessons. So if you have time, have a look with these videos, and I promise we will bring you to different results. Okay, we'll pay the sandbox. Yeah. Last week, some of the students told me that Hong Kong you bring their student to Disneyland, right? I will I will refer to our senior manager and say that yeah, Hong Kong is doing like that. So can we do more? Can we do similar things, or can we bring you guys to other exhibition? I will try. But honestly, I will promise you will have in this year you will have at least five visitors, and then we will coordinate with Hong Kong XRA. We will pay the money for your visitors. So Hong Kong XRA promise us. Every month they will provide one visa. So together maybe you will have five. Will have um 10 plus 5, maybe you have 15, this kind of visas. Design you whether you can join or not. I will try to organize this kind of exhibition or this kind of activity with us in the Saturday PM. So you come to my class and then you PM you can go and travel, pay with the other things in Hong Kong. So hopes that we can do more. And one of the important things for this kind of the visas is help you to make fast. So similar to the things I mentioned in the last week. So your project one, are not only your project one. So this project and also mixed reality, all the project in our university request you to form group. So try to know more about your student. Pay with your classmate, pay with interact or communicate with your classmates. So you yeah full activity yeah so you can make fast and then in the project one or you can put in the project two you can make sure that you find the correct presence for your project. Okay, and of course we receive the campaign for the fee rider. So if there is some fee rider, let me know. Okay. Next one is yeah. Next one is concerned about the final format and all sorts of the solution. So we will discuss all the new format or new directions about the metaverse. So any Blender, 3D Studio Max or Maya user here? Hey, no. Do you know how to build object in Blender? Okay, don't worry. Next week we will have next week we have the workshop for the Blender. So we will help you to build something from the Blender. Okay. Whatever. So yeah, I guess some of you guys are you have the background because I have screened your CV and then know you. Some of you are from the multimedia, some of you are from the games, and then some of you guys are from the yeah design school, right? So you have experience in the computer graphics. So don't worry. And then it's a good that we try to yeah we try to gather different directions, different background people together. So if you know how to create the 3D graphics well, so try to find some programmer. If you are a good programmer or AI developer, try to find someone that know about the human needs and then they can generate some business solution, new idea, whatever. Okay, so back to our class. Maya, Blender, Video Studio Max, or also things, they are traditional company, traditional company. So Maya and also Studio 3D Studio Max, so they are come from Autodesk. Autodesk, they combine together and then to yeah they are not combined together. Autodesk buy the two products and then make them together. And then they have their because they are private company they have their own file format. They have their own file format. For example, Maya. So Maya, they have the MAMB file format. And then for the 3D Studio Max, you have a .max format, right? So the format is the intellectual property, is the assets of the private company. They will not share the format. They will not share the advance of this kind of file format with you, right? Right? But in our computer world, it's an ecosystem, just like we have mentioned in the first lesson. So we want the metaverse become a share world. So all the file format, all the technologies we will share with each other. So we want some open format. So around 10 years ago, computer world, VR, AR, and then yeah, VR, AR, and also the games technology, computer graphics, they try to develop different open file formats. And this kind of open file format, they can share with each other and then they can create something new and you can use this kind of file format to create your metaverse. So today when you want to create the metaverse, do not use the .ma, .mb, .max file, etc., Blender file, etc. Okay, try to use some open source format because when you're using some open source format, you can you can ensure that your files, your model can be used in different platforms. Okay, so the first one we are going to learn is the GLB. GLB. So GLB is a binary file that is dedicated for the 3D model, scenes, lighting, materials, and all sorts of the animation for the 3D object. So if you are paying the FBX, or if you are the Microsoft DR, you're paying about the .x files. So GLB, so is a it's a replacement, open source replacement for this kind of the FBX, for this kind of the private company file format. So it's easy to share, and then it can be loaded by different platform. 3.js or the Omnia platform, they can load the GLB files. Okay. So GLB file, it can be, yeah, easy understanding. It can divide into two things. The first one is the binary, GLB. The second one is the GLTF, JSON file. So binary means that, oh, okay. So in the Maya, you also have the MA and MB. MB is the binary. MA is the ASCII code. ASCII code. ASCII code and also ASCII is similar to the JSON file. That means I can double click, open it, and then read by the notepad, read by the human. So there are points information. There are lots of the modifier information. There are lots of the things that can be understood by human. So this one, a ASCII file, JSON file, that means the GLTF, they belong to something that human can be understand. GLB is binary. What is binary? Zero 1, understand by computer. So I would like to ask which one is better. In these lessons or next lesson, we will always ask about the justification, right? Compress, uncompress, GLB, GLTF, FBX, .x, etc. We'll always ask which one is better. So which one is better? Which one is better? Again, the answer is it depends because they are both of them they exist, right? So definitely they have the advantage and disadvantage. And because of your usage, because of your application, you have to select different things. If something that is one time, that means it's launched to one. Okay, it's ready to run, and then you will not modify by the human anymore. GLB. GLB is read by the human. Sorry, it's read by the computer. Computer can run the binary files faster. Okay, if it's one time, you not modify again, GLB. So this one, JSON file, right? So you can understand and read. You can use the program to modify. If you want to edit a little bit, it's still available. So if something is not ready to launch or not ready for the runtime, you can keep it as the GLTF. GLTF. Okay. Okay, got it? Got it? So we have different kinds of the comparison. And then GLTF is good because it's JSON file. You try to yeah, it try to tell you that where is the texture. So just like the .x file, so you tells you that hey, the texture is in the same folder and the name is abc.tiff, etc. Okay, so can I change the texture file right now using the GLTF? Yes, you can. But if you become a GLB, yes, you have the texture file. But the texture file is FA, COB, COV, etc., etc. All the things are primary. So can you edit it again? Very hard. Okay. Okay. So two files depends on your application. Still want to it? Modify the texture file. Modify the texture file. For example, modify the content inside it using the JSON one. One time using the primary one, GLB. But mostly today, when you download from the internet, they will only give you the GLB because they do not want their product or their 3D model can be modified by you. So most likely they will only give you the GLB. Okay. So yeah, and GLB, yeah, less computation power, less processing is good for the one time. At least 33%, one third, smaller than the others, smaller than the GLTF. Okay, so this one time perfect. And then whatever is JSON file or whatever you are using the binary files, so we will pad it and then put it inside the different package. Today, Blender, 3D Studio Max, Scratch, and also all the 3D scanning and also the OpenSea, etc. And what else? OpenSea and then NFT and then oh and then what else? I cannot think. Spatial.io and also I'm sorry, I just forgot the name. Whatever. All the 3D platform they support this one. Okay. Our, around 10 years, starting from 2000, almost 10 years, starting from 2015, 2016, we start to have the GLB file. And up to now, all the big company, all the online platform, OpenSea platform, Spatial.io, they are ready for this kind of file format. So do not, if there are some 3D modeler and then if there are some artists that they still use the FBX, do not allow them to do so because if they are publish the FBX to you, sometimes it's a little bit different, and then you are not able to cross platform support from the others. Okay, so do not allow the user to use the FBX. Yeah, we always talk about FBX. So what is FBX? Do you know what is FBX? FBX file. When you are creating games, you always have the FBX files because it's a Maya or Blender creator. So usually we will prepare the 3D object with the skeleton, with the texture, with all the things, animation together, and then output to the Unity or output to Unreal to use. And this FBX. FBX is from the Autodesk. FBX is from the Autodesk. Again, this one is private company. They will not share their assets. They will not share their secrets with you. But I would like to ask, compare FBX and GLB, which one is better? GLB, open source versus private company assets. Which one is better? Open source format or private company format? Again, the answer is depends. Yeah. So always remember it depends can be used in lots of the situation if you cannot think about it. Yeah, it depends. Right now, the running time of the FPX is still good. The performance is still good. So if you are running something that you will not share in different platforms, for example, I would like to build a VA game in PS5, okay? Spider-Man or a Monkey King, etc. FBX is still a good choice because Monkey King, I will not use the 3D model and put it into Metaverse and then do other things, right? And the performance right now, because Autodesk, we spend a lot of money. The performance of FBX supporting high details of image, supporting better materials of lighting, different modifier is still perfect to use. The performance, the support is better than the GLB. Maybe 3 years later, GLB will be better. I don't know. But right now, Autodesk is still here. Autodesk is still continues to improve the FPS file format to support more materials, more lighting, better performance. Okay, they put lots of the resources. So if you are doing the VA games in PS5, FBX. But if you are going to share in different platform, and then yeah, in the Metaverse platform, GLB. Okay, understand, right? VA games, open world, open source, Metaverse platform, GLB. Okay, so what else? Yeah, so here GLB is also famous for the web browser, web browser. So if you are using the WebGL, if you are using the 3.js, then GLB file format. So do you know that someone create another Mario Kart by using the GLB and by using the 3.js? Do you know? So nowadays there is a not few months ago, around 8 months ago, so there is someone create a exactly the same Mario Kart using the V.js and then using the GLB. Now you can open the browser. You can open the browser in on your iPhone or a tablet and then play and then modify all the object and then create new games again. So what's the meaning of this one? It's similar to the Warcraft 3 and then the LOL. Do you know the LOL coming from the Warcraft? Yes, right? The LL, 绑姐荣耀 coming from the LL coming from the Warcraft 3. So if someone interested in this kind of development and become the open source, soon or later, so there are lots of different similar gameplay will be here. And because of lots of the player will play this kind of game together, so maybe you will create a new esport or new game world environments for all the players. So this one is interesting. Okay, so what else? GLB. And also, for example, which one is over there? Yes, and also, so Vision Pro, which one should I use? PS5, this one, right? Web, Spatial.io, Metaverse, Omniverse, this one, right? Vision Pro, which one? GLB or FBX? GLB. Okay. I don't know why, but Apple's always keep their format, keep their all sort of things into a really top secret, and then they only want to develop their own environment. So you have iOS, right? They do not follow the Android, they have the iOS. And then they have different developing environment. But talking about the metaverse, talking about the AR development, they follow this line. So they use the GLB, they use the USD, and then they are reality composer using this kind of format put into it. Restraint, but they are using, maybe they hate FBX. So last lesson I told you the Flash and then the Apple, right? Steve Jobs hate Adobe. So I don't want Flash in iPhone. Maybe Apple also hate FBX because FBX, Autodesk, and then Pixar is coming from the similar situation. Steve Jobs owned the Pixar many years ago, and then he left the Pixar and then back to Apple. So there are lots of this kind of interesting story. And maybe it's not technical, it's all because of the political, whatever. Apple, Vision Pro, go to GLB. Okay. And when we are talking about Steve Jobs, we're also talking about not only Apple, we're also talking about the Pixar animation, okay? Pixar animation. So Pixar create lots of the animation, and then this animation is is a factory production. So don't think that the Toy Story or Elsa Frozen is created by a small group of people. So there are thousand, 1 or 2 thousand animator 3D model. They co-create the animation together. Okay, and now you need to manage so many animator to create the things. So you need a better management platform. You need a better organization for this kind of the animation production. So Pixar invent or produce the USD. Okay, USD, not US dollars. Is universal scene description, universal scene description, USD, USD. USD is somehow to synchronize or have a better production line to let the animator to share the workflow. So maybe we can have a better understanding with this graph is easier. So yeah, it's just like here. So USD is a common format. It's a common format for all the Unreal, Blender, and also all sort of things to describe the scenes. So what is inside the scenes? GLB is describe the 3D object. Okay, GLB is describe the polygon, the texture, the animation, the skeleton. So what is USD? What else is inside scenes? Do you know the difference? Object and scene, they are different, right? GLB is for the object, 3D object. So 3D scene, what is inside the 3D scene? Inside 3D scene, you have the 3D object, right? So you have the 3D object position. You have the 3D object timeline. Inside the 3D scenes, you also have the lighting. You also have the lighting. Okay, so they have the information of the scene environment. Lighting is one of them. You also have the rendering. So I should render the skin, I should render the texture, even the TIFF file format. So there are different layers. So which layer you should render. So those are the scene description. So try to remember that GLB is for the object. USD, Universal Scene Description, is for the scene. Okay, scene description is for the scene. So with this kind of situation, you can have a better understanding. So there are different animator. So they are create 3D object one by one, one by one, one by one. And those are the GLB format, or maybe FBX, I don't know, whatever. GLB also, USD also support the FBX. They support the Blender file, they support the Photoshop, they support different files. So when the animator and when the 3D model create the 3D model, they will give the 3D model to the USD. And the animator will try to use their 3D model to do the animation. And then they will add the animation inside the scene descriptor. And for the other, for example, I'm doing the lighting, I will add the lighting information into the scene description. Okay, into the scene description. So they will add more. And for the other, for example, I'm the rendering, I will add the rendering. This guy is for the computer graphics programmer. I will add something for the computer graphic, etc., etc. And that one, this one is the USD. This one is the USD. Whatever you are using, the Photoshop, Maya is here, and then Unity, Unreal, etc. I support all the format. And all the format now can be added by the other without we have the tracing lot, right? We have the lot tracing. So somehow I can know who is modify which part, and then I can undo this part. They have the version control, and this is the USD. USD. Have you heard about Alien Brain? If you are doing the Maya or 3D Max animation. So many Max goes, so there is another management tools called Alien Brain to support the multiplayer or not multiplayer, multiple 3D model or multiple designer to create the video world. This is called alien brain. And then USD is replacing the alien brain. Okay? Okay? Is that clear? Is that clear? Clear. Okay? So back to here. Back to here. USD is going to integration difficult. Yeah, it's going to solve the management problem. Management problem. There are too many people doing the same one product, and then I need to have a better management, version control, log checking, and then better sharing, etc. So they are solving the integration problem. They are solving the integration problem. Allow all the people they can share the video object, lighting setting, all this kind of thing together. And it's good because Pixar in 2016 they released the open source this kind of the UST, this kind of the software. So with them to release this kind of software, so the other companies start to support. So now again, if you are Apple, follow the UST. If you are going to use the Metaverse creation, Omniverse creation, follow the USD file format. Yeah, USD file format. What else was this one? Yeah, so this one is a better understanding for what's going on. So you have the USD. USD can store different materials, different lighting, different camera, different geometry setting, different asset setting, etc., etc. Okay, so they are scene descriptor. They are using to describe the scene settings. So what is materials? What is the difference between materials and texture? I forgot to mention this part. Yeah, materials. I haven't mentioned, right? In a 3D object, you have the polygon. On the polygon, you have the texture. You also have the scan and you have the animation. But what is materials? What is materials? What is used for? I forgot to mention, right? Materials is not texture. Okay, materials is used to describe the physics of these 3D objects. Okay, for example, what is the material of this bottle? Plastic. Okay, plastic is not texture. This one is the texture. Okay, plastic is the materials. So what is the physics behavior of plastic? Elastic, maybe. Okay, and then they have also different lighting. Okay, lighting. For example, they have the reflections, they have the gravity, falling speed, they have the rebouncing force, etc., etc. So they are materials. Materials is the physics of the object. Okay. Sometimes the materials is not handled by the 3D modeler because artists, right? Artist, I'm learning art, I'm learning design. What is physics? I don't know physics, right? So I don't care anything about plastic. I don't care anything about the lighting, about the reflection of the plastic under the night, under the sunshine. I don't care. So there are someone with the physics, they will produce the materials, they will produce the physical equation for the artist to do it. So also have this one, and it's also under the USD. So you know that now you know better USD here. It's not GLB. It's not talking something about the 3D object. It's talking something that by the physical developer, by the lighting. What is someone work for the lighting is the lighting, right? Or lighting staff, lighting. I don't know. I'm sorry. Lighting. Someone work for the camera, etc. USD is working for this one. Okay. And then what else I should discuss? Uh, yeah, geometry. Yeah, I guess I have. So the ultimate goal of USD is NVIDIA want to work with Apple, want to work with Pixar to re-simulate a digital world. Okay, their ultimate goal. So these three community, they want to work together. Okay. So this one is from Steve Jobs. This one is also from Steve Jobs. And then NVIDIA is going to create the chips. So they analyze together and then develop the GLB, develop the USD, and then next step, they want to develop a digital twins of the whole world. That means inside my whole world, inside my virtual world, so you are able to define the materials, you are able to define the physics, you are able to create another digital virtual world by using my technologies. So that is their ultimate goal. Okay, okay. Now our next step is talking about digital twins. Is talking about the Omniverse. So Omniverse is the format of the NVIDIA. So Apple, Pixar, so they are doing the software, right? They are doing the final format. So what is the role of NVIDIA? Hardware. So yeah, why I need hardware? Stupid, right? So why I need hardware? Hardware for hardware for. So this too is easy to understand, right? Apple, Apple, I'm not sure what they are doing. So anyway, Pixar, they do a USD. USD is the scene descriptor. GLB is the file, is the video object descriptor. So they are doing the software, they are doing the file format, and then you know that the video they are doing the hardware. So they are building the infrastructure of the Omniverse of the digital twins. Infrastructure, that means I provide the platform for you to do all the rendering and physics. NVIDIA is famous for two things, three things right now, AI also, and maybe four, AI robotics. So this is their new direction. But traditional, NVIDIA is famous for their rendering and also physics. Okay, so they would like to simulate a digital world, and that is what they are doing. So they want to produce, next one, example, they want to produce, I'm sorry, Omniverse. Omniverse, okay, Omniverse. I'm sorry, I missed two slides. The Yeah, one of the things of the USD is called Hydra. Hydra. Okay, have you watched the Marvel? Hydra. So they use the Hydra, they use the shield, they use the Marvel setting. So Hydra is here. Hydra means that I have different computation power. Sometimes you run in the RTX, sometimes you run in the Apple, right? Different GPU, they have different computation power. So Hydra means that I can set the level of the rendering. So if I meet some computation power that is really low, I cannot render so many, so I will decrease the lighting resources. I will decrease the calculation. So now all the calculation of the omnivores of 3D world become more flexible and dynamic. Depends on the user. You send on the device. I I can change the generation. I can change the rendering timeline. That's interesting. And then, yeah, but nothing special. Honestly, we don't care a lot of the things of Hydras because we have Omniverse. Omniverse. NVIDIA produces Omniverse. Omniverse is a platform infrastructure. We call it PaaS. So platform as a service. Could I know what is the difference between SAS, PaaS, and IaaS? Computer science, right? You have learned SAS, PS, and IAS. Of course, there are another one, blockchain exact surface or other thing exact surface. I don't care. The traditionally we have three levels: SAS, surface exact surface, platform exact surface, infrastructure exact surface. So what is the difference? Infrastructure exact surface. That means I only produce the server. Okay, I only produce the hardware, the server for you. So you come here, I produce the data center, I produce server, I produce the networking. You can install the OS, you can install the database system, you can install the web system, etc., etc. You can build by yourself. PaaS, platform as a service. That means I not only produce the hardware, I also produce the VM, virtual machine. Inside the virtual machine, there is ready to use OS, also web server, and also the database server, etc. You can select, you can click and select. You need not to do the installation. And they also provide the development tools for you. In this one, Omniverse is PaaS. PaaS. They provide the hardware. They provide the infrastructure. That means it's okay. I help you to provide the networks of your game. I help you to provide the GPU, greater GPU. I help you to provide the GPU to rendering. I help you to provide the GPU to calculate the physics. And then I also provide the management tools, USD inside my hardware. That is the role of the NVIDIA. So inside my hardware, you need not to install anything. I help you to install all the software as you need, and then provide the developer to use. So PaaS here is for the developer. And what is SAS? SAS is Gmail. That means that you are not developer, you are the end user. So SAS is somehow I provide Gmail, Google Docs, and also Google Map or other kinds. Game is also a SAS. Okay. But here, Omniverse is a PaaS for the developers. For the developer, provide the USD, also provide the hardware, provide the infrastructure for them to use, and provide the network for them to use. Okay. Omniverse is here, and then you can have a look with the Omniverse. So yeah, they have end user, yeah, a developer. Okay, whatever. So you have a game company here, and then for example, Tencent, but Tencent they haven't used the Omniverse. I use this, maybe I use another, Ubisoft. Okay, Ubisoft. So Ubisoft connect with the NVIDIA Omniverse, okay, NVIDIA Omniverse. They buy the platform. So all the developer, all the 3D designer, now they need not to install the USD by themselves. This one is the VM, virtual machine. They will offer the USD. They will offer all sorts of the synchronization problem to all the developer and then the 3D designer. 3D Max is Autodesk is here. 3D Studio Max Blender is also here. Unreal is also here. So I would like to ask, hey, something is wrong, right? Game engine, Unreal. Do you know how to use Unreal? We'll teach later. But what is the game engine that you know? Unity, right? Ah, where is Unity? Right now, the Unity they cannot produce the live sync. Okay, that means for you, for this part, if you have create something, modify something, you can sync to the Omniverse, upload to the Omniverse, but you cannot download. That means someone, for example, 3D Studio Max or Maya or other developer, they have created a job here. You cannot download their job back. It's useful, useless. It's a management tools. I'm not sure that Unity will support the Omniverse later, but last year they did not support. Up to now, this year they do not support. So we yeah, can I say that? I hate Unity. Lots of the individual developer hates Unity, so there is a long history. I run global game jam for 12, almost 12 years. So I'm the host of Hong Kong Global Game Jam for 6 years. This year I will pass to another guys. I'm retired. So we observe the change of the Unity. At the very beginning, Unity, we support the individual developer. So there are lots of tools. They update their system really well, and then they communicate with the individual developer. So it's easy to use. So lots of the individual developer or lots of the small game company they use Unity. One 4 to 5 years ago, Unity want to escape from the individual developer. They want Unity want to get the money from the individual developer. If you heard, last year the stock price of Unity dropped 30%. Do you know why? Huh? Exactly, remember because the CEO of EA Sports go to the Unity and become the boss. So have you paid the EA Sport? You hate, do you love EA Sport? Yes, because they just want to get the money, right? So they have the NBA, blah, 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 and then you cannot observe the difference, but you have to pay the money. They just modify a little bit. So EA Sport is famous that they just want to get the player money. And now this situation moved to the Unity. So the Unity design the bro is I just want to get the money from the individual developer for all the games that is created by the Unity. They are not only charging you about the platform fee. Exactly, remember the platform of Unity each year is around 30 something, 30,000. If you buy all the pub in, it should be 30,000, something like that. It's not really expensive, but they want to get the share of your product. So if your game is success, they will get around 30% from your game. It's a huge amount of money, right? Unreal, the starting price of Unreal is huge. The starting price of Unreal Game Engine is 1 million. So if you want to buy Unreal, it's 1 million. But in this few years, it's better. Around 4 years to 5 years ago, similar to Unity escape from our individual developer. And Unreal launch give us the educational license. So educational license is free of charge. And I hate Unity because many years ago we have the voting license. So around 6 years ago, we paid money to Unity to buy the education license installed in this kind of PC. Now, when you are using our PC, we are using voting license. That means we have the image from our server sent to your PC and then once the image, run the VM, right? It's common, right? And then Unity do not support this kind of voting license server. So the money I pay, yeah, I pay to the Unity, and I cannot get their product because we are running the VM, we are running the voting server. They do not support the voting server license. And up to now, around 3 years, so still we cannot get the product. We just give the money to Unity. Yeah. And there are lots of interesting story. Unity support the global game jam, a huge event of all the individual developer. And then because Unity argue with the individual developer, so they set up another game jam. Yeah. And then they want to argue with all the small community, with all different kind of small community of game developer. So that's why lots of the game developer right now hates Unity. Yeah. And don't think that the Unity is can cooperate with the other. See that? They argue with the Omniverse, right? They argue with the NVIDIA. They also argue with the Apple. Now, Vision Pro support the Unity, but the support is only you create Unity games. The 2D Unity game can put into the Vision Pro. Do you understand what's the meaning? That means that you are not create a VR game inside the Vision Pro. You are create a 2D game with a big screen, and then you can get the gamepad and then play the gamepad using the gamepad to play a big screen inside the Vision Pro. So what's the meaning? So yeah, it's really funny that similar to Adobe. So yeah, Unity the NVIDIA hates Unity. Apple also hate Unity, and our individual developer also hate Unity, and that's the situation. Yeah, it's fun. Yeah, better here is undirectional. Undirectional. So only Unity can upload the file to the Omniverse, but no synchronization from the Omniverse from the other developer to the Unity. So if you want to do this kind of synchronization, then that means that you need to call your designer to get the FBX and then put it back. Or another way to do it is Unity X the final stage. So that means all the developer has complete all their work. And then the Unity, they can modify by themselves and then upload and then get the train. That means your game is launched. Your game is launched, and then you have some new update. You can use this kind of format. If it's only works format, that means the designer and also the game developer they are updating the metaverse together. This one doesn't work. Okay, this one doesn't work. Okay, So yeah, that's fun. What else? Yeah, I've told you that, right? Omniverse is a PaaS, platform as a service. So it's a cloud service, and then they provide the hardware together with the software that for the developer and also for the 3D modeler to use it. Yeah, so nothing special. I've discussed. Yeah, if they success, so one, there is only one internet. Okay, internet they are connect with each other. Okay, there is only one internet. And if they success, there is only one metaverse, and it's called Omniverse. Because all the developer they contribute the same file format, they added the biggest, largest metaverse together. So if they are success, Omniverse will become the one and the only one metaverse in the world. I'm not sure Apple together with NVIDIA they will success or not, but that is their final goal and then to do it. Okay. Yeah, open USD. And then what else? Else we can okay. Still 15 minutes. Ah, nothing special. NVIDIA material definition. NVIDIA physical X RTX. I'm not going to sell NVIDIA. But honestly, if you want to become rich, perhaps NVIDIA is still good to buy it. Okay. We always buy the stock in our lab, but yeah, we always lose the money. Bank special here, extension manager. Yeah, what is the integrate development tools in the Omniverse platform? So they provide different tools for the developer to add. For example, they have the extension manager for you to manage some plug-in of 3D Studio Max Maya, Unreal, etc. They have the interactive documentation. So just like GitHub's, and then if you modify something, they will the developer will try to type in something, type in the documentation. This one is really important because they have the version control. When multiple users they are editing the same document, editing the same UI coding, so you need a version control to roll back, or to a certain point that you can use. Okay. They also have the omniverse.ui.framework. So the UI framework how to modify the rendering pipeline in a very short time, and then you can add it. Yeah, they have the 3D viewport for you to for you to view the 3D scenes. So can I edit the 3D scenes inside the Omniverse? Can I? You can edit the object position. You can edit the lighting. You can edit the materials. You can edit what else? You can edit the programming, UI, etc. But for the 3D object, GLB, you have to ask the developer. You have to ask the designer to upload it again. Okay, okay. This one is for management. It's not for create the 3D object. Got it? Ah. Yeah, they have the Visual Studio for the developer to type in the program to modify the materials, to modify the physics rendering inside it. And then they also have the server surface for you to run a virtual Earth, digital twins Earth on their server, on their infrastructure. So yeah, there are lots of interesting demo they have created. For example, because they want to have a digital twin, so they always create lots of interesting physics, interesting application, killer application for them. For example, they try to create the digital human. So inside this one, you are able to use the Omniverse tools and then tool. They are first one, you can use your photo and then upload here, yeah, and then you can generate 3D object, and then using the 3D object, you can tune a little bit. You can also use your audio input and then generate different speech to it. But honestly, this kind of application can be done in conversation AI and other AI platforms. So you need not to buy the Omniverse platform, but still they have this kind of editor for you to create the digital world. And then they also have the another team to simulate the physics, to simulate the gravity, to simulate the collision detail. And they have another direction using the AI to understand the video and simulate the physics. Do you know the difference? So now they are working on two directions. First direction, using the transitional physics expert to rewrite the formula, and then use the computer science to implement the physics inside the physics, and then one to their game engine. Another one is we have already lots of the video, right? Analyze the videos, understand the physics inside the videos, and then using the AI generative content to generate the physics animations, to generate the animation or generate the effect inside the Omniverse. NVIDIA now they are working in this tonight. So now they are not only working in rendering and in physics, they also work in the AI part. And later on, they want to step into the robot. So that is their pipeline of development. If they success, honestly, they can own the virtual world. Yeah, post checker, we'll have this one later. So yeah, so I guess we have finished most of the content, and then yeah, within these 5 minutes, we'll do some housekeeping. The first one is go to the so every week will be like that when you go to the course. Oh, it's fundamental. Yeah. So after 1 week, here, Metaverse 2D, 3D fossil, and then you will get all the peer review videos. Okay, you will get all the peer review videos, and then you also will get the slide here, and then you will have the questionnaire. And questionnaire will be due next Monday. So you have time right now. So try to go to the Google Forms and then complete the questionnaire together with I was one. I hate. I hate this PC. Okay. So go to the questionnaire and then complete 1 or 2 minutes. And then yeah, if you have completed questionnaire, this is the end of our lessons. I will be here and then answer your questions. And also next week will be the sandbox. The sandbox. If you are not computer science background, if you are not developer, come and learn the sandbox. Because your project one and project two, you can use the sandbox as your development case. Last year, last year, yeah, let me show you some example. It's easier. It's good. Yeah, you find some some of the project is not really attractive. And then I'm asking, so if it's not so attractive, why don't you use the sandbox as your development case? Because if you are using the sandbox, so at least your graphics and then at least your demo will be more attractive. And this one is zero coding. They have the infrastructure, they have the NFT, they have the fossil editor. That means the blender that you need. They have some a little bit programming language, Okay, it's really easy. It's just like Scratch, action bar, and then link it together, and you can complete the application. Okay, honestly, if you are not developer, you can find the suitable tools to finish your project. Do not charge your ability. Okay, so next lesson, the sandbox will be here. And then have you heard about decentralized auto organization, DAO, DAO, DAO? Yes, right. Some of you guys heard about. So and so you have the cryptocurrency, crypto, and then you have the NFT. The next trend will be the DAO, DAO. So how to use the Web3 environment and then Web2 environment to create some business, to create the application inside here, inside the Web3 environment. So next lesson, Eric will also come to tell you about DAO, how DAO can be worked inside the sandbox. So it's a perfect solution for the non-developer to do your project. So at least next week I will be here and come and learn a little bit about the sandbox. Okay, and it's good because the sandbox, the company, and then the boss, they are all here, and then we have some good connection. So yeah, try to make a good use of our connection, and that's it. Thanks for your coming. So see you next week. And then if you have any questions, come and ask.